Hello everyone, welcome to the SSCA online webinar. In this presentation, Professor Dharmesh Raykundaliya is going to present his new paper that is being accepted for publication now in the volume number 24 and issue 1. The paper is on an inferential study of two Kumaraswamy population under joint rank set sampling. Professor Dharmesh, congratulations on these new publications.
Thank you, sir.
We will make it available on YouTube as well. So please go ahead, make your presentation. You have 10 minutes. So yeah, go ahead.
Yeah.
Thank you.
Thank you very much for giving the opportunity by the Society of Statistics, Computer and Application for organizing the wonderful activities to present our accepted research paper so that it can have a more visibility and researcher can have an idea to understand the entire paper in a few minutes of time. Yes, I'm Dr. Dharmesh P. Raykundaliya. I have jointly written this paper with my research fellow Mahesh Bhingikar, an inferential study of a two Kumaraswamy population under the joint rank set sampling. So this is the abstract of my paper. What is the motivation behind that? In medical and biostatistical studies, particularly in analysis the lung cancer related data, researcher often encounters variables that are bounded, skewed, or expressed in the form of proportion and rates. Accurate modeling of such data is essential for reliable inference and decision making. Classical distributions such as the beta distributions are commonly used for the bounded data, but often involve computational complexity in estimation and simulation. In practical setting, especially in medical studies, data collection can be expensive or the time-consuming, necessitating efficient sampling strategies. So traditionally, sampling methods like simple random sampling may not fully utilize available ranking or auxiliary information. Therefore, there is a need for a flexible and computationally efficient probability distribution and advanced sampling scheme that improve estimation efficiency without the increasing cost. So we have coined the idea of the joint rank set sampling. Most of the rank set sampling schemes reported in the literature are based on the samples from a single population only. When the product comes from more than one production line, then the joint sampling schemes appear. Raykundaliya and Patel have discussed joint rank set sampling, joint modified rank set sampling, joint percentile rank set sampling for the exponential distribution, whereas Patel and others have discussed joint rank set sampling and joint modified rank set sampling for the Rayleigh distribution. So why we are going for the joint rank set sampling? The key advantage behind that can enhance estimation efficiency by using information from a multiple population. Useful for a comparative study where the both population needs to be analyzed simultaneously, and helps to reduce the measurement cost in a multi-population studies. So how the joint rank set sampling is working? So let us consider we have a two population X and population Y. We select the M1 unit from a population X and M2 unit from the population Y. Arrange this as the initial matrix. So these are the M observation of a set size M1 we have taken from the X population. Similarly, M such set of a observation set with the M2 from a population Y. We combine them together. So total we have a population sample size is a M, that is M1 plus M2. So we are arranging, we are keeping the data in this way. This is the data from the X population. This is the data from the Y population. This is the set 1. Similarly, we have a total M set. So it is a M cross M matrix. But these observations are without ranking. Now, what we are doing, we are ranking the observation and we denote them as a W. So W11 is nothing but it is a observation, the minimum observation from the set of X and Y. Similarly, W12 is nothing but the second minimum observation from the first set of a combined observation. So similar way we are arranging this observation. Now, what exactly we are doing in the joint rank set sampling? We are selecting the first minimum from the first set, second minimum from the second set, and the nth minimum from the M set. And so this is become my first sample. So such sampling scheme I am applying, repeating this particularly scheme K time. So I have a total observation is these are the M observation because it is M cross M matrix, diagonal M elements, and I am repeating this K time. So total we have a MK units, and that is nothing but my sample size. So in other way, we say that Wij is not represent the ith rank unit in the jth combined set. So there is another rank set sampling that is called the joint minimum rank set sampling. Why we are going for this? It is easy to implement, and especially it reduces more cost and time as compared to the joint joint rank set sampling. It is useful when the selecting minimum unit is easy as compared to other rank, because we are selecting only the first unit from the each set. So it is a minimum unit, and when it is required, we can go for this. So similarly, again, the algorithm is same. We have taken the M1 set, M1 observation from the set X, M2 from the set Y. We combine them and arrange, and we are selecting the first minimum from each set. So this is the first minimum from the first set. This is the second minimum from the, this is the first minimum from the second set, first minimum from the ith set, and similarly, first minimum from the M set. So this is my selected sample, each having a size M, and I am repeating this particular process K times so that I have a total MK unit, and that is nothing but the small n is equal to MK. And for a maximum, we are repeating the same procedure when we are interested for the especially maximum unit, when it is easy to obtain the information. This in a similar procedure, we are going to arrange the data and we select the maximum from the each set. So this become the my sample from a one cycle. I am repeating this for the K times. So total I have a n equal to MK observation. Now we have a likelihood from that, because as I say that we have a M unit, and I am trying to select the ith unit from this M. So, and ith observation is nothing but my order statistics. So I'm applying the concept of the ith order statistics. Here the capital Fx is nothing but the CDF of a population X, and small fx is nothing but the PDF of population X, and capital GY is nothing but CDF of a population Y, and GY is nothing but the PDF of this. Here I am using the total I have MK observation. So it is a product of this Aij, Bij, Zij. So Aij is nothing but the number of observations of X which is less than or equal to Wij. Wij is nothing but it is the ith observation in the jth set or the jth cycle, but we don't know that whether it is from the X observation or Y observation. So Wij we have information, and now we are trying to identify how many observations are less than or equal to the Wij. So that is Aij. How many observations of Y is less than or equal to Wij? So it is Cij. So naturally, Bij is nothing but the number of observations from the set, population X. It is succeeding the Wij. Zij is nothing but it is an indicator variable. If Zij takes value 1, then you have taken the sample from the population X, otherwise population Y. If we substitute the Aij and Cij equal to 0, then of course it is a likelihood for the joint minimum rank set sample, because minimum, the Wij itself is the first observation. Similarly, if I am going for the likelihood for the joint maximum rank set sampling, I have to substitute the Bij and Dij equal to 0, because largest observation is we are taking, so there is no observation succeed the Wij. So that is not that is we are taking the 0, so the likelihood can be reduced to this form. As I mentioned that Zij is 1 if the Wi is from the population X, 0 otherwise, and this is the nomenclature. Aij is a number of X observation less than or equal to Wij in the ith set of a combined sample of a jth cycle, and similarly Cij is nothing but number of Y's observation which is less than or equal to Wij in the ith set of a combined sample in the jth cycle. The idea behind the joint rank set sampling and the likelihoods are given. But why we are focusing on the Kumaraswamy distribution? The Kumaraswamy distribution is a flexible and analytically tractable probability distribution defined on the interval 0 to 1. It has gained significant attention in a statistical modeling due to the following reasons. analytical simplicity. Why? Because beta distribution CDF does not have a closed form, but the Kumaraswamy distribution has. It has a flexibility because it has a two shape parameters. It can model a wide variety of shapes, including increasing, decreasing, unimodal, and U-shape density. Because it has a closed form is available, so you can easily generate a sample from the given distribution using the quantile function. It is a wide application in the hydrology, income distribution modeling, and reliability analysis. It is alternative to the beta distribution, as I already said, because it has the bound 0 to 1. So, it is specially focusing on the proportion and rates, which is restricted to lies between 0 to 1, and compatibly with advanced sampling scheme. So we can show further that it is showing the better efficiency compared to other sampling schemes. So these are the PDF and the CDF of a Kumaraswamy distribution from a population X and population Y. Here A1 and B1 are the shape parameters from a Kumaraswamy distribution when the sample is taken from the population X. Similarly, A2 and B2 are nothing but the shape parameters for a Kumaraswamy distribution for the population Y. So just naturally, we have to substitute the CDF and PDF in the likelihood of the rank set sampling, because our basic idea is that we wish to go for the maximum likelihood estimation under the various sampling scheme, and we are also trying to see the performance of the estimator under the various schemes. So we have taken the log likelihood, and of course we know that to obtain the ML estimation, we have to take the first derivative with respect to parameters, shape parameters of the first population. And
Professor Dharmesh,
yes,
please try to close your talk in another 1 or 2 minutes. Thank
okay, sir. Thank you. So similarly, we had obtained the ML estimation, their information metrics for the all possible rank set sampling scheme, and we had compared with them with the joint simple random sampling. So these are the performance tables are given. So we had performed the simulation. We have taken the different size of a sample from 3, 4, 5, that is M1, and M2, that is 4, 5, 6, and we have repeated this particularly cycle 2, 3, 4, and we have obtained the ML estimate, and we have obtained the bias as well as the root mean square errors. So these are the tables are given, and it is showing that for a various sampling scheme, the joint minimum range sampling scheme has the especially lower root mean square error compared to the other rank set sampling. However, if you look at the joint rank set sampling, joint minimum rank set, and joint maximum rank set sampling, it has the better performance than the joint simple random sampling. We have also evaluated the likelihood ratio test, where we are finding the particularly testing the hypothesis when the shape parameter of the first population and the second population is identical when another shape parameter is known, and it has shown that as the sample size is increasing, the joint rank set sampling having the better power compared to other rank set sampling. We have considered the one cancer data that we have taken from the cable, whether the individual having a lung cancer is present or absent, and these are the variable which are affecting the particularly patient about the lung cancer. We had applied the probit models. Last 1 minute, sir. We have applied the probit models, and we have predict the probability of the lung cancer, and we have fitted the particularly Kumaraswamy distribution on that. So based on Hoshman-Lemshow test, it has been shown that the model is fitting well. We have divided into the two-part data is from the male and female, because our idea is that we should apply the joint rank set sampling. We had applied the Kumaraswamy distribution for the combined as well as male-female, so it has fitted well. So finally, we had used for the same data, and we proceed for the simulation. At the last, we say that the joint rank set sampling has the better power, but if you look for the performance based, it is saying that the joint minimum rank set sampling is better compared to all other joint rank set sampling, and especially all joint rank set sampling having a better performance compared to the joint simple random sampling. So these are the few references. Thank you very much.